Welcome to Solving Systems Using Algebraic Methods. Today we're going to look at the method of substitution. Please pause the video and record the information following here, which is the four-step process we're going to use to solve using the method of substitution. The first step will be to pick one of the equations and isolate one of the variables. Sometimes the problem will begin already with a variable isolated. Sometimes one of the equations might have a variable with a coefficient of 1, and that would probably be the variable you're going to want to isolate since it'll be the easiest one to get alone. In step 2, we're going to take the equation from the first step and replace it into the variable in the second equation. That's the actual substitution process. In step 3, we're going to solve for the variable now that this new equation created in step 2 is all just in the same variable. We're going to be able to solve for it. Solving will entail reversing orders of operations. We'll also have to do a little bit of simplifying along the way in that step as well. In the fourth step, you're going to take the result in step 3, which is the value of the new variable, and put it into one of the original equations so that you can solve for the second variable. If the problem is a real-world problem, you're going to want to use your answers and give labels and answer in a complete sentence. We're going to look at 2 examples, and please take the time to record everything that you're about to see here so that you have that in your notes. The first example is the system negative 3x minus 8y equals 20 and negative 5x plus y equals 19. In the first step of the 4-step process, what we're going to want to do is isolate one of the variables. So if you look at what we're starting with, we don't really have a variable isolated yet. We don't have an x equals or a y equals anywhere. So the next thing to analyze is there a variable that has a 1 in front of it? So with this x, we've got a negative 3 here for the y, negative 8. Here, negative 5 in front of x, and then finally here we actually do have a 1 for a coefficient. So that's going to be the variable that we're going to start with to isolate for step 1. So in isolating this y, we're going to actually move this term over to the other side by adding the opposite. So we're actually going to add 5x to this side, and that will remove that value there. So for our first step, we're going to have y equals 19 plus 5x. In the second step, we're now supposed to take what we just got and substitute that information into the other equation we haven't used yet. So basically this y value here, I'm going to want to take this information and put it into the y in the other equation. So that would be this y right here in the first equation that we haven't used yet. That y is going to get replaced with the 19 plus 5x. So we're going to start with the negative 3x minus 8. And that 8 is multiplying to this y here, but now it's going to multiply to all this. So I'm going to open up parentheses because it has to multiply to several things here when we actually simplify, equals 20. The third step is solving for the variable. Now that we have a new equation, it's got all x's, okay, no mixed x and y's, it's all x. We have to begin finding what is the value of that x. So solving will mean we're going to reverse PEMDAS, but we always have to be simplified before we do some solving. And every time we kind of do a step in solving, sometimes there's simplifying that has to happen at the same time or before that as well. So we do have some simplifying that needs to get done, and that is this distributive property here with the negative 8. So we've got negative 3x. We have negative 8 times 19. So that'll give us a negative 152. Then we have negative 8 times 5x is going to give us a negative 40x equals 20. So that's a little bit of simplifying. We have some more simplifying before we start with solving, as we get to combine like terms here, our x values. So we'll have negative 43x minus 152 equals 20. And then now we're ready to solve. We're going to add 52 to both sides of the equation. So that'll be 172. And then we're going to divide out the negative 43. And so when you do that, I think you get x equals negative 4. Positive divided by negative is going to be negative. In the fourth step, we're taking the new x value and putting it into one of the first equations so that we can solve for y, and then we'll get our ordered pair x comma y. It doesn't matter which of the two equations you pick. Sometimes I kind of go with the equation that's got smaller values that seem to appear to have less work. So I picked the equation that's negative 5x plus y equals 19. So that negative 4 is going to go in here for x. So that's really a second substitution that we're doing here in this problem. So you substitute, a little bit of simplifying before we isolate this next variable. So we're going to subtract 20 here. 19 minus 20 is going to give us negative 1. We finish the problem by giving a nice ordered pair, x comma y. Since this is not a real world problem, we don't really need to report our answers with units of any kind. Here's our second example. So in this system we have variables c and d, and again in our first step we want to pick one of the variables to isolate. So again, looking for a variable that's already isolated. We don't have that in this problem, but we do have a variable with a coefficient of 1, and that's this c right there. So that's the value that I'm going to isolate by moving this 2d over to the other side. So to do that, I'm going to add the opposite. C will be by itself, and I'm going to have 4 plus 2 times d. For step 2, I'm now going to take this result and substitute it into the other equation. So it's going to go and take the place of c in this first equation here. So now I'm going to have 3 open parentheses, 4 plus 2d. I still have the minus 6d there. That's originally in that equation. I have the equals 12. The next step, step 3, is solving for the variable we have now, which, remember, will also include simplifying. So I do have some simplifying. I have to distribute that 3 into the parentheses, which gets rid of the parentheses. So distribute, then combine like terms if there are any. So I have these d's here that will combine together. And what's actually going to happen there is we've got 0 d's, right? Interesting. So if there's 0 d's, it means there's no d's at all. We've got 12 equals 12. So what we've got now is actually a special case where our variable canceled out completely. So if the variable cancels out, we're now left with a statement in front of us that says at this moment in time 12 equals 12. So what does that mean? That means we kind of have to look at what happens here with the 3 types of solutions possible with solving a system. So a quick summary here. Again, you're going to need to record this. You kind of did this already with the graphing method. So with substitution, what does that look like? One solution will mean that you're going to be able to solve for both variables and come out with an ordered pair at the end. That was like example 1. No solution means that your variable is going to cancel out, which is what happened just now in that second example. The end statement, however, will look like a number equals a different number. So that is not what we had in our situation, because we had 12 equals 12. Those numbers are the same values. So let's take a look at infinitely many solutions. Both variables cancel out to 0, which is what happened with the d's. And the end statement will look like a value equals the same value. And that's the situation that we just had in example 2. So you can go back there and fill in what that problem is there. It's got infinitely many solutions, which means if we graph this, it would be the situation where you've got one line graphed exactly on top of the other line. So they're actually the same line. The answer we want to give, though, is how many solutions possible, and we say infinitely many solutions. That is the end of this lesson, and I'll see you in class to do a little bit more practice.